Up until now, we have only been dealing with the production of one output. Section 7.5, the final section, deals with production with two outputs, and we will be looking at what economies of scope entail. Now, can you think of examples of firms producing more than one product? So I can think of Honda as a manufacturer of both motorbikes, superbikes, and cars. And there are lots of examples where firms would produce more than one good. If you think about poultry, you have chickens and eggs. And there may be other examples where goods are related, or just by virtue of it being a byproduct, it makes sense for the production of both products to take place, or the products may be completely unrelated. So we need to ask ourselves, why would this be the case? Well, it may be the case because there are cost advantages of producing more than just one good. So it may make sense to produce more than just one good and produce two goods, for instance, because perhaps you could share production facilities or share the same kinds of expertise, skills, a joint facility or plant. Perhaps the same marketing or administration team could deal with it. So there are cost advantages that need to be considered. So we need to evaluate these advantages of joint production. And for our analysis, we are going to begin with looking at figure 7.12, which shows a company that produces both cars and tractors, right? So you have one company producing both cars and tractors, which are two different outputs. So we are going to use a device called a product transformation curve, and that is these two curves, O1 and O2, that we are referring to in figure 7.12. These are product transformation curves. So a product transformation curve is a curve that is going to show the various combinations of the two different outputs. So here our two different outputs are tractors and cars that can be produced with a given set of inputs. So we don't see the inputs here, but we know that there is a given set of inputs, let's say a combination of labor and capital that is used in fixed amounts to produce this particular output of tractors and cars. So there's a number of things that you need to note about the shape of these product transformation curves. So if you look at the shape, you can see that it is bowed outward or concave. So that tells us something that we're going to reflect upon in a moment, and that is economies of scope. If you also look at O1 versus O2, you know that O1, here we've got some combination of labor and capital that was used to produce these two outputs of tractors and cars. So there is some degree of inputs used to produce this output. But in order to go from O1 to O2, in this scenario, there is a doubling of inputs. So we've increased how much inputs we have in terms of the labor and capital that can be used to produce that output O2. So this expansion takes place as a result of obviously using more inputs in the production. So hence that O2, that product transformation curve, is further away from the origin. It is above and beyond O1. So it uses double the inputs and hence it is more than O1. Now also note the slope of these curves are negative. So it also tells us that there is a trade-off taking place. You can see that it's downward sloping and negative. So if a firm were to decide to produce more cars as opposed to tractors, of course, it would then use those inputs to produce more cars instead of tractors. And that is the trade-off, right? In order to have more of the one, you are going to have to give up some of the other. Now, lastly, I want to come to the point about the shape being concave, bulging outward or bowed outward, as you could say. Now, if you were to look at O1. Here we have O1 if it were a straight line. Now, if it were a straight line, you would have a scenario where it didn't matter if you had one firm producing both products jointly, or if you had two firms, two separate firms producing each product individually, because the output that would be yielded would be the same. So there would be no benefit or advantage. However, because the curve is bowed outward, there is economies of scope in production. So there is some benefit to one firm producing both goods jointly, both outputs jointly. And that is what economies of scope in production entails. So let's define economies of scope and diseconomies of scope. Now, economies of scope is a situation in which the joint output of a single firm is greater than the output that could be achieved if two different firms each produced a single product. So think about my Honda example. You could have two different firms, each producing a single product, one producing motorbikes, one producing cars. Now, with economies of scope, a single firm producing both outputs, that joint output is greater when that single firm produces it than if you had two different firms doing it. That is economies of scope. Now, diseconomies of scope is a situation in which the joint output of a single firm, Honda in this case, the joint output of, let's say, Honda producing both motorbikes and cars, that joint output is less than what could have been achieved by separate firms if each produced a single product. So here it would make sense if each one firm produced motorbikes and one firm produced cars, because then the separate firm's output is more than a joint output of a single firm, and that's diseconomies of scope. So you have now encountered returns to scale, economies of scale, and now you have economies of scope. So please do not confuse these concepts. They are all different, and there isn't a relationship, for instance, between economies of scope and economies of scale. You could have a situation where both economies of scope and diseconomies of scale can exist for a particular firm. So you need to understand these definitions very clearly. And also, in each case, there is an application where you could measure your returns to scale, your economies of scale, and now you will see we can also measure the degree of economies of scope. So, to measure the degree of economies of scope, in order to do that, we need to ask what percentage of the cost of production is saved when two products are produced jointly rather than separately. So here we have our measure or our formula. This is to calculate your degree of economies of scope. So here this represents the cost of producing output Q1. So just producing one output. This represents the cost of producing your output Q2 minus the cost of producing both outputs Q1 and Q2 divided by the cost of producing both outputs Q1 and Q2. So remember, it's the percentage. We must ask what percentage of the cost is saved when two products are produced jointly rather than individually, right? So this is the formula, equation 7.7, that you would use to determine that degree of economies of scope. Now, if we were to interpret it, you would have a situation where if you had economies of scope in existence, then the joint cost, must be less than the individual cost. Then you would find that SC is going to be greater than 0. And if there are diseconomies of scope, and you want to measure that degree of economies of scope, then this SC would be less than 0 if diseconomies of scope were to be in existence. So lastly, you can just go through this example 7.7 that deals with the economies of scope in the trucking industry for your own knowledge enrichment purposes. And that concludes chapter 7. Remember, section 7.6 and 7.7 is not prescribed.